This video we explore the derivatives of tangent and cotangent, secant and cosecant. So I'm going to give you the proof of where they come from, and then I'm going to do a few examples with them. Okay? So the first one is we're going to derive the derivative of the tangent, because we've already done the derivative of sine and cosine, and we know the tangent is the quotient of those two. So we're going to do f and g, and we're going to see what the derivative of tangent would be. So f would be sine of x, f prime would be cosine of x, g is cosine of x, g prime is going to be negative sine of x. So f prime of x is going to be f prime g, because remember again the quotient rule is f prime g minus f g prime all over g squared. Alright, so I have f prime g, so that's cosine squared x, minus f g prime, so that turns to a positive sine squared x, all over cosine squared x. Okay? So I look at it and say, oh yay, I see this happening again. I have the cosine squared plus sine squared, so that is my identity. So that's 1 over cosine squared x. So that is a derivative of tangent, and you could call it secant squared x. So now we know if we had f of x is tangent of x, now we know the derivative of tangent is going to be either, you can say 1 over cosine squared x, or you can call it secant squared x. And remember, trig functions yield trig derivatives. Okay? Now let's try cotangent. We're going to do the same thing and see if we can derive what the derivative of cotangent is. So here's our f and g's again. We're going to do a quotient rule. So f is cosine x, f prime is negative sine x, g is sine x, g prime is going to be cosine x. So f prime of x is going to be f prime g, so I have a negative sine squared x, minus f g prime, so I have a negative cosine squared x, all over g squared, which is sine squared x. Now we're going to do like a little math trick here, because I see I have sine squared and cosine squared, but they're negative. So if I factor out a negative 1, that changes it to sine squared x plus cosine squared x. And now you see why I did that, because I can use the identity over sine squared x. So again, here I go. These two are going to add up to 1. So negative 1 times 1 is negative 1 over sine squared x, okay? Or you can call that negative cosecant squared x. So if your function is cotangent of x, then f prime of x is going to be either negative 1 over sine squared x, or negative cosecant squared x, okay? So let's look at two more. Let's do secant and cosecant. Alright, so we're going to do the quotient rule again, and we're going to make sure that we show how we derive this. I just had to plug in my laptop. Sorry, it was dying. Okay, so we're going to do f and g to figure out how we come up with a derivative of secant and cosecant. So here's our f and g again. So f is 1, f prime is 0, g is cosine of x, and g prime is going to be negative sine of x. So if we do the derivative, f prime of x is going to be f prime g, so the first term is gone, minus f g prime, so that turns to a positive sine x, all over g squared, which is cosine squared x. Alright, now we're going to do a math trick. right? So we're going to actually split up this fraction. Now, how you would do that is this. I have a cosine times a cosine, so I can really write it like this. Sine of x over the cosine of x times 1 over the cosine of x. Do you see what I just did? Because there's your cosine squared. Then we can have some nice trig functions here. So sine over x is over cosine of x is tangent of x. And 1 over cosine is secant of x. So the derivative of secant actually has secant in the derivative. It's tan x secant x. I actually usually write it the other way because it's easier for me to remember. So I usually write it this way. Secant tan is how I say it. Secant x, tan x. Just, it's a little bit easier to remember. All right, now we're going to do cosecant. Here's our f and g's. We're going to do the same thing. So f prime of x is going to be f prime g. So our f is going to be 1, and our f prime is going to be 0, just like the last one we did. Our g is the sine of x. G prime is going to be cosine of x. So f prime g, and when I do that, again the first term is gone, minus f g prime, so that makes it a negative cosine x all over g squared. Now we're going to do the same thing. We're going to split this fraction up, so we'll have some nice trig functions to use here. So I'm going to do negative cosine of x over sine of x times 1 over sine of x. And when I do that, I have two trig functions. So cosine over sine is cotan, so it's negative cotan of x. And 1 over sine is cosecant of x. And again, I rewrite it because I want to, if it's the derivative of cosecant, so if cosecant is first, I like saying it first. Same with if secant's first, I like saying it first. So I'm just going to say it's negative, just got to remember the negative, cosecant x, cotan x. Okay, so we just found out all the derivatives of all 6 trig functions, and here they are. I've got tan is secant squared, or we said it's 1 over cosine x squared because I use it that a lot. Cotan is negative cosecant squared, or negative 1 over sine squared x, which I use. Secant is secant tan, and we usually just leave it that way, and this is again how I remember it. The secant is there, and cosecant is first there. It's negative cosecant cotan, but don't forget the negative. That's important. Okay? Now let's do 4 problems to practice this, and then we're going to do more in class, but this will just give you a little taste of how you work on these. So we're going to do some here. So I've got g of x is secant, cosecant. And you have to recognize what you have on the outside here, and I see I have a product. So my f is going to be secant of x. My g is going to be cosecant of x. So have your derivative card out there or start memorizing. The derivative of this is going to be secant tan. G prime is going to be negative cosecant cotan. So these are both co-functions and they're negative, okay? And let's put it in here. So I have g prime of x is going to be f prime g. So you actually have this weird looking thing here, cosecant x times secant x tan x plus fg prime, which really is negative, so I'm just going to put the secant in front here. Okay, so now I have that, and if you would like to simplify this, if you'll notice you have all these different things. So sometimes what makes it much easier is if we put everything down to the building blocks, which I call sine and cosine, and then you'll see where some things hopefully will cancel. So cosecant is 1 over sine of x, and we're multiplying it by secant, which is 1 over cosine of x, times sine of x over cosine of x, minus secant, which is 1 over cosine of x, and cosecant is 1 over sine of x. Cotan is cosine of x over sine of x. Now, the reason why I did this is because it's multiplied. this has really sine in the numerator and cosine squared in the bottom, if you see that, but the sines will cancel out. You can do that. Here the cosines will cancel out. So you end up, which helps simplify this a little bit. So I always try to do this sometimes. So I end up with 1 over cosine squared of x minus 1 over sine squared of x. And then you can revert back to what they are. Well, 1 over cosine squared is secant squared of x minus cosecant squared of x. So this kind of, you're back into what you had before. So I had secant times cosecant. Well, this is what the derivative would be. So this middle step kind of helps do that. All right, let's look at h of x here. So I have tan x minus 1. So here there's no product rule, no quotient rule, so I can just start doing the derivative. So the derivative of tan we found out to be secant squared, or 1 over cosine squared. So let's try this first. Secant squared x minus 1. Okay, so I look at it and say, I wonder if there is something I can do with that. So I try to think of all my, derivatives that I have. Not derivatives, but our identities. And there is an identity that does this. So if you don't recognize it, you can kind of keep going and come up with it. But really, there is an identity, and I'm going to show you where it comes from, that tan squared of x equals secant squared of x minus 1. There's one of the identities that we talked about before. So I could say this is tan squared of x. But say you didn't know that or you forgot. So watch what we're going to do this. H prime of x. Now I'm going to rewrite this. Secant squared is 1 over cosine squared of x minus 1. And then we're going to do a common denominator. So when I do that, I have h prime of x equals, and this is all over cosine squared of x. And so when I do that, I have 1 minus, and then I multiply by cosine squared of x. Now this is more of an identity that I know, because I know sine squared of x plus cosine squared of x equals 1. So if I have 1 minus cosine squared, if I move this over here, this whole numerator is sine squared. I said, okay, cool. So I have this, sine squared of x all over cosine squared of x, and sine over cosine is tangent. So a lot of times you're doing the derivative. So if you'll notice, this right here is really the only calculus you did. You did the derivative. But then all this, I'm using identities and inverse functions and things like that to come up with our final answer. All right? 2 more. Now I have a quotient. So here's our f and g. So let's set it up. F is the cotan of x. F prime, so get out your card so you can remember, is negative cosecant squared x. G is 1 plus cotan of x. G prime is going to be a negative, because the derivative of this is 0, and the derivative of cotan is negative cosecant squared x. So it's kind of the same thing. Now, let's do this. So I've got I prime of x is f prime g, so I have a negative cosecant squared x times 1 plus cotan of x, alright, minus fg prime, but it's already negative, so it's plus, and then we're going to do cosecant squared cotan x all over g squared. Alright, now I look at this and I was wondering if I could factor out or make something better, and I see that both, this is a term right here and this is a term right here, and do you see where they have cosecant squared in common? So I'm going to factor that out, see if we can make this look a little nicer. So if I factor out, and I'm going to factor out the negative too, so it's going to change the sign. If I factor that out, what's left is 1 plus cotan of x in the first term. If I factor out a negative here, it changes it to a minus, and all I have is a cotan x left. And do you see what happened? Which is, you're hoping that something like that will happen, that it'll simplify a little bit. So I can say thanks for playing with these two. It's like goodbye, they're gone. That's a 0. Okay, that's gone. That's a 0. So I end up on the top is negative cosecant squared x times a 1, so it's just negative cosecant squared x all over 1 plus cotan x squared. And we're not going to go any further, so there's your derivative. Okay. One more left, and this is the product rule, so this is going to be f and g's. So f is going to be x to the 5th, f prime is 5x to the 4th, power rule. G is tan x, g prime is going to be secant squared x. So I have j prime of x is, and this is product rule, so it's f prime g plus fg prime. So I got f prime g, so I have 5x to the 4th tan x plus fg prime x to the 5th secant squared x. So I have j prime of x equals, now here's a term here, you got to look and see if we can factor this or simplify it, and I see I can take out an x to the 4th out of both those terms, so I do. See if anything exciting happens or if that's it. So I got 5 tan x plus x secant squared x. That's a 2, guys. So that's all we can do. I don't think there's anything more. I'm just making that look a little nicer. So that concludes this video where I did a couple problems, so be prepared to come in class and practice some more.